this, and if I see what would correspond to basically a very unreasonable value of that regression coefficient under the null hypothesis, then I'm going to assume that the null hypothesis must be wrong, which means that I will reject it and conclude what we call the alternative hypothesis. You always construct the null hypothesis so that well, basically, generally you're going to construct the null hypothesis so that it corresponds to there being no relationship between the x variable here, so wages, and the outcome. So then as soon as you reject it, then you conclude there is a relationship. So to actually like derive this distribution, again, there's statistical theory underlying that, which we won't really go into. But what you'll see in the papers is they're going to report sort of two things. First of all, they'll report the regression coefficient, which is beta 1, and then they'll report what they call the standard error of that regression coefficient. So that basically corresponds to like the standard deviation of the regression coefficient. And so it turns out then that when you take the ratio of the coefficient divided by its standard error, that ratio is distributed approximately normally, with a mean of 0 and variance of 1 is actually the t-distribution, which is a little bit different than the normal distribution, but you could think of it as being pretty much the same. And so then if the true beta 1, the actual coefficient in the in the population, like if you had an arbitrarily large data set, the actual coefficient that you would observe or that you would estimate is equal to 0, then the probability of observing a t-statistic, so that's the ratio of beta 1 divided by its standard error, that's greater than 2 in absolute value, turns out to be 5%. So basically what that means is that we have this rule of thumb for statistical significance, where if the t-stat, the ratio of the coefficient to standard error, is greater than 2 or less than -2, then we say that the coefficient is statistically significant, and if it's less than 2, basically it's in the range between -2 and 2, then we say that it's statistically insignificant. What that means, so saying that it's statistically significant at the 5% level, what that means is that if the true beta 0 or the true beta 1 were equal to 0, then the probability of estimating a coefficient that was as large as the one that we saw or larger is only 1 in 20. And since that seems unlikely, so like there's no like sort of underlying theory as to why 1 in 20 is the threshold for unlikeliness, and like personally think it's sort of probably not as conservative as it should be. We should probably have a higher standard for statistical significance, but it's just like basically somebody proposed it like 100 years ago and people just stick with it. So right now, the threshold for sort of thinking that something is unlikely to be due to chance is that if we see that it was more likely than 1 in 20, then we think that it's relatively likely, and if we see that it's less likely than 1 in 20, then we think that it's too unlikely to be due simply due to chance. So since 1 in 20 odds seems sort of unlikely to actually occur, or a 1 in 20 event seems unlikely to actually occur, we reject the hypothesis that the true beta 1 is equal to 0 and conclude that there is in fact a relationship between x and y. So when I was like first trying to introduce statistical significance to the people in this course, it was like coincidentally it happened right around the time that Steve Jobs died, and this was like 2011. And so there was like it actually, so just by coincidence, it created this interesting illustration in my opinion of statistical hypothesis testing. So I'm going to sort of lay out the scenario and then have you guys discuss in groups whether or not you think that the event is statistically significant. So essentially what happened was, it must have been like October or something like that, but basically every year in the fall, Apple released a new iPhone. So I think the timeline was something like I don't know, maybe it was September. So I'm just going to make up a date. So basically it was something like September 20th. Apple announced 2011, so it must have been the iPhone 4S, I think, which at that point was like the new model. So this was, and this was like they had like a press event and stuff like that. And then the next day, they announced that Steve Jobs had died. And so the question that I sort of posed was whether or not these two events are related. So in particular, you could sort of imagine a hypothesis that basically that he was kind of waiting around until the next major product introduction, not like literally waiting around thinking I'm gonna make it to then and then I'm gonna keel over, but more like sort of subconsciously kind of waiting around for the next major thing, and then after that it's sort of spend all your energy and at the end of it. So basically the alternate hypothesis would be that there is in fact some relationship between these two events. So I guess you would basically say the announcement had a causal effect on him dying, and the null hypothesis would be that the two events are totally unrelated. So formally, the way that we would say that then is that the probability of Jobs dying was constant or equal across all days, right? So that if you sort of can't, you don't know exactly. Well, I guess you do actually. So the probability that he died on sort of any given day in the year was always identical. And then so that's the null hypothesis, and then the alternate hypothesis would be basically the null is false. So whatever is implied by the null being false, which in this case would be that in fact the two events are related. So my claim is that basically just using the definitions of statistical significance that we have gone over, that you guys can already tell me whether or not there was a statistically significant effect of the announcement on his death. So I want you to break up into your groups, and I guess almost like 11:50. So discuss sort of whether or not you think it's statistically significant, and then in the last few minutes I'll have one or more groups sort of give their opinions and their reasoning behind whether or not these two events are related. You're right, it was the Siri year. Okay, so is there a group that wants to volunteer to give their answer of whether or not they think? Okay, you guys are 8, right? Okay. Mm-hmm. Okay. So why would you? So you're saying you would accept the null hypothesis? Unrelated. Okay, is there a group that disagrees with that? Group 7, which is already you guys are already.
We were saying that like the stress of like if you die like already time like we were saying like maybe like the way you kind of like if you say like your spouse dies, like you die a week later kind of thing, and your body's gonna go down. So one series of births, then you
Well, so you're describing the mechanism. Oh, so let's back up for a second. So you guys are already describing mechanisms. You haven't taken a stand on whether you haven't taken a stand on whether or not you think that the two events are related. So implicitly, you seem to be saying you think. So you're saying you reject the null hypothesis. Group 8 says they accepted the null hypothesis. Group, you guys are 5 or 4? Okay. Yeah, that's true. Okay, so group, what do you guys? You guys are like, wait, where are you? You're like over. Yeah, I know. Okay, I just thought you were maybe 4. Okay. So right now we have 2 accepted, 1 rejected with mechanisms, and you guys are. Well, yeah, potentially. Although you could, so the question then would be though whether or not the stress was in fact caused by the announcement, right? So like if the announcement causes the stress, which then causes him to die, then that would actually be an effect of the announcement on his death. So that's something that we haven't really talked about yet. Is that when we say controlling or like keeping all other factors constant, what we actually mean is like keeping all other factors constant other than factors which themselves would have been caused by the original event or like the treatment that we're talking about. So that's, I mean, it's something we'll like discuss later on. But in the scenario that potentially there could still be a causal relationship between the event and his death, even if there was sort of the stress like variable intermediating the two. Is there sorry.
So how do you probably dying people on all days? Like this is actually like could you say something along the lines of like arranging days or like like you say like 30 days around the release for higher stress and then stress is like a component, or is it every day something every day?
Yeah, so I mean for this we're on the right. So I mean I said like it's an equal probability of dying on like any all days. Right. So that and okay. So wait. So let me respond to that in a second. Let me just see. Are there any other groups that want to share their opinions? No. You guys are 1, right? Okay. Yeah. So yeah. So that's my fault for not like sort of wording it maybe quite as carefully as I could have. So when I said equal on all days, I kind of meant like equal on any given day of the year, not taking into account of what year it is, but just like on any given day of the year. So like if I tell you that the day is September 21st, and like I tell you, okay, I'm gonna like kind of go into like I have a calendar that runs for infinite time, like from beginning of time to end of time, and I draw one day it's September 21st, and then another day is like January 2nd. Which of these days is later? You would have no, well, so I don't know the year. One like I can't tell. I have like no hypothesis about whether one is later than the other. And so it's true that as time progresses, obviously everybody's chance of dying increases because everybody dies eventually. But the day of the year that you die on, not like the actual date, but the day of the year, is not necessarily related to, or like there's no higher probability of people dying on a September day than there is on like a February day or something like that. Like, so that's evenly distributed. Okay, so group 7 is correct in that I would reject the null hypothesis. Group 8, so you guys like had all the calculations right. You guys are like the only ones who actually gave a number. I'm not quite sure why though you then concluded that you would accept the null hypothesis. So you were exactly on it, right? You were basically saying there's like a 1 in 365 or maybe like a 1 in 182 or whatever, depending on sort of whether you want to use like a 2-day span occurrence or a 1-day span of him dying on a given day, right? So under the null hypothesis, right? So then what we're saying is that the probability that these 2 events occurred like on simultaneous or back-to-back days is very low under the null hypothesis. It was only 1 in say certainly no higher than 1 in 180, right? So that's a pretty unlikely event. Therefore, it seems unlikely that the null hypothesis is true because under the null hypothesis that was just not likely to occur. Therefore, we would conclude that the alternate hypothesis is in fact correct because we rejected the null hypothesis so that they are related. So I mean the way that like the very sort of simple intuitive way to look at it is just that it's a very strange coincidence that these 2 events were separated by only 1 day, right? So either it was just a very unlikely event, there's a very strange coincidence, or in fact there is some relationship here. Now whether or not, it's not to say that when we're talking about like he died of pancreatic cancer, right? So I'm not saying that he wouldn't have died ever had the event not occurred. I'm just saying like maybe his death would have come like 2 weeks earlier or 2 weeks later had the event not occurred on that day. So it's just talking about sort of shifting the exact date of his death around, which is something that happens. I mean, you'll see like people survive past Christmas or something like that, and then die. Like there was actually like a spike in death rate for the holidays and stuff like that. But, okay, so we will continue on Friday with the